My name's Stead, and we're doing Learning Kotlin as a C# developer. If you're in the wrong room, it's too late, the doors are locked, you're stuck. But no, seriously, if you want to go see another talk, that's fine. I won't judge too much. So, kicking off, I wanted a little bit about me. I don't normally do this sort of thing, but I feel today it's kind of relevant. I work for a company who's paid me to be here, which is awesome, called VQ Communications. And we are hiring remote developers. Come talk to me. No, me. And secondly, you should completely follow me on Twitter for the simple reason I could be doing this in fancy dress right now, but I didn't get enough likes. So, you know, you've all missed out there. I'm sorry. Anyway, let's talk about what we came to talk about, Kotlin and C#. So I'm going to start off with an excuse. I'm still learning Kotlin. I just think it's really cool, and I think everybody else should go learn it too. I feel like I'm comfortable to talk to you all about it. If you ask me some really hard questions, I'm not going to be able to answer them. Simple truth. And as I learn more, my opinions and understanding of things will change. So, where do we begin? I've split this talk into 3 parts. The first part is a bit of the background of what and why Kotlin, how it comes into play and how we can use it, and how it works. The second part is Kotlin itself as a language. We'll jump into how the language looks, how it works, and have some code on screen and go through that. And the third and final part is Kotlin and .NET side by side, comparing it. Now, I was a little bit ambitious when I decided to do this talk, in that I was going to introduce you to a new language, teach it to you, and then compare it with another language in 45 minutes. So, in honest truth, we've got a lot to go through, and hopefully we do it all, otherwise this is going to be a disaster. So, first off, what and why Kotlin? So I've come up with some questions that you may have. Does Kotlin have NuGet? Why should I learn it? What is it? Will Iron Brew ever taste the same? No. And you may have heard that it's on Java or the JVM, and that's a bad thing. So we're going to jump into that first, I guess. So the first thing to talk about is Kotlin as a language. Is Kotlin a language for you? So Kotlin itself is a language made by JetBrains. They obviously do tools for loads of different languages. They've got C#, Java, Python, PHP, JavaScript, Go, Ruby, loads. So it's not, what they've done is essentially taken the good parts out of all of those languages and built Kotlin. It's not a functional language, it's not an OO language, it's a bit of everything, and it's certainly not an experimental language. It's not coming through science, it's tried and tested, good bits out of this language we're putting into Kotlin, which makes it really nice to use. But the question you've all got is it a Turing complete language, right? And that's definitely true, but I think that's so 1983. If we want to use a language now, we want to know, does it compile to JavaScript? And the answer is yes, it does. You can compile to JavaScript with Kotlin. You can also have Kotlin native as well, which is what it sounds like. It's just itself an application that you build out, and it's got no dependencies on the machine itself. It's a native thing. Okay, so we're going to focus on the JVM side of things because the JavaScript stuff and the native stuff is still, I believe, in preview and being actively worked on, and I'm still learning it, so that's just going to be a disaster. So we're not doing that. We're going to talk about the JVM bits. So, this is where it gets interesting, I guess. To talk about the JVM bits, we need to talk about Java. And oh my god, Java. Who here is a .NET developer? Cool. All but one person who said they're not a .NET developer at the start. Brilliant. So when you hear Java as a .NET dev, you think, oh my god, Java, what the hell is that? It's bad. But Java, unlike C# and .NET, is kind of poorly named for what it actually is and what it's referred to. So there's 3 parts to Java, I guess. The first part is the language. So you've got Java as a language. And if we compare that to .NET land, you've got C#, you've got F#, you've got Visual Basic. That's pretty much dead now, I think. In Java, you've got Java, Scala, Kotlin, Groovy. There's loads, Clojure. There's loads in that space. So when we say Java, we don't mean the language here. We mean it's a language on a platform. The other part is the ecosystem. So this is where you think of the .NET framework and the BCL, I guess. So the libraries you use, okay? So in Java, there's the JDK, also referred to as Java, and that can be used in Kotlin, Scala, and things like that. It's the same thing. So when we say the ecosystem, think of the .NET libraries that you use, okay? And finally, the platform, how it runs. And at this one, think of the CLR. Think of the stuff that takes your IL and makes it run, right? The jitter, things like that, garbage collector. That's on there too. So it's a similar setup, but a little bit different, okay? So when we talk about Java, we mean all 3 of these things. Not just the language. So don't be scared by it all. Need to talk about the JVM a little bit, because that's where Kotlin's going to run. It's not Java language, it's JVM. So JVM bytecode is the equivalent of IL in .NET land. So we really need to know about it. I'm not going to go into too much detail about this stuff. It's cross-platform, and it's cross-platform out of the crazy versioning of .NET Standard and .NET Core, except there's loads of crazy versions in Java too. So we have that problem there, sort of. It's just not quite as bad. So things to be aware of is you've got the JRE, which is the thing that actually runs your code. That's the runtime environment. And then you've got the Java SE, which is the JDK. You have the Java EE, which is the enterprise version of the SDK. So it has all the SE stuff and some. And you've got the Java micro edition. These all have different version numbers. And just like .NET, it gets very confusing very quickly. So I'm not going to go into that too much. Just be aware that the JDK is our thing that we build our code against, and the JRE is where we run our code. And that's true with Kotlin as well as Java and anything else on that platform. Make sense? Cool. Java applications. I'm going through this bit really quickly because it's kind of dull, but I feel like it's a good setup. Class files, that's what you essentially ship, but you'll ship hundreds of them, so you zip them up into a jar file. It's a glorified zip. Think of a DLL at that point, I guess. And there's no MS build, so we have no horrible XML stuff, but we still have to build things, obviously, otherwise it would be a scripted, interpreted language. So building stuff, there's quite a lot of options in the Java space. The main one, I guess, is Maven, or one of the main ones is Maven. And Maven also doubles up as your package dependency manager thing. So that will build things as well as pulling your dependencies from a NuGet type source, okay? But that's all XML based, and it's kind of not really popular as far as I can tell now. Most people tend to use Gradle, which you can use Kotlin to script out, and you can use Kotlin to build your Kotlin. It's quite cool. There's also like IntelliJ has its own build thing as well. There's Ant. There's loads of them, but yeah, these are the two main ones. And Maven is particularly important because of the package manager. And all of this stuff is kind of dull. So let's move on to the interesting parts, a look into the language itself. So the first thing I'll say is Kotlin is quite fun. And I've done a witty play on words. What am I like? So in Kotlin, there are functions. And to define a function, you do something like this. Okay? So it's a method, but it's declared just like that. All right? Really, really simple stuff. You'd see this sort of thing everywhere. And if we annotate that a bit, we've got our parameters. We've got our parameter types on the right-hand side of the parameters, not like C#, where it's the left-hand side. The return type is on the edge of the method. And there's no semicolons, unless you want semicolons, in which case you can put semicolons in, and it doesn't care. So if you want to have an argument with your team, don't have white space, no white space. Have semicolon, no semicolon. Way more fun. But this is a kind of a simple function. It's not really doing much. And it's quite a lot of code for just a simple add function. So we can start to rewrite it a little bit. So we see this in C# now with expression bodies and things like that. So we're seeing it more and more in other languages too. So you can have a function that looks like that. But of course, the type can sort of be inferred. You add two integers together, you're getting an integer. So of course you can drop that too, and the function becomes that. So if there's no return type, because that's inferred completely. The compiler knows that's an integer, you know it's an integer, you don't need to explicitly say that. Make sense? Cool. Oh, and you can do other things as well. You don't just have to do arithmetic, you do branching logic in there too. Okay? But this is all really, really simple, quite basic stuff. Let's step it up a little. Let's talk about var and val. So everyone knows about the var keyword in C#, right? If you don't, it's just a way of not putting the type on your variable. The type's inferred. Kotlin has the same thing. You can have a var, and you don't have to declare the value of the var right there. You can just say it is an int. And then you declare it on the UI, and you can reuse it as much as you want. Or, of course, you can let it infer the type, which looks a little bit more familiar to C# purpose, where var x is 42, and you can change that over time. Make sense? That's essentially C# in semicolons at this point, right? What about val? Val is a little bit different in that it becomes a read-only property, read-only variable once you've set it. So you can only set vals once. So you may be able to see there's something assignment here. There's a little red squiggle underneath x. That's because I've already said it once. So I can't set it twice. The compiler is saying no, it's read-only at this point. So think read-only fields in C#, but not confined to the constructor. It's read-only everywhere. Or, yeah, just think about it. And again, we can assign it on the same line and use type inference to get rid of the int thing. Make sense? Var and val difference summed up. One you can change, one you can't. Got it? Cool. You sure? Yeah, cool. Right. That's a super high level look at things, but doesn't really make any sense in isolation. So we're going to introduce a class. Now, there are loads of different ways of doing this in Kotlin. There's different types of classes, companion objects. There's loads of things I can't talk about because I haven't got time. So I'm going to try and keep it as simple and high level as possible so we can discuss the language and discuss the code and get a good understanding of what it feels like to write Kotlin without going crazy, right? So that is a class, that is a full class. There is no more code you need to write for that class to work. So we've got a constructor, it's a primary constructor. I'm not going to get into constructor differences too much. And you'll notice we have a person name and a first name as a parameter and a second as a parameter, and they're both strings, right? You'll also notice that I've used the keyword val next to it as part of my parameter icons. What this will do is make properties which are read-only for that class. So if I instantiate a person name class, I can call person name.first, and it will give me the value for free. I haven't got to write that property myself. So Resharp and Rider has a quite handy feature where you can type C or P, and that will complete your constructor with all the property values in for you, so you don't have to write it all out yourself. Kotlin goes one step further and says, well, there's no point writing the properties, we know that that is a property that you're going to use. So it does it, exposes it for you. If you don't want to expose it, stick the private keyword in front of it, it makes it private. Okay? If we want to do that in C#, we're looking at more than, significantly more than one line. I would say a guess at 10, but I'm completely guessing it. We can also make it so we can set one of those properties. So because they're auto properties essentially, we can say if we want to make this a setter, so the second name we're going to change, we make that a var instead. And that'll say, okay, I'm going to put a setter on the second name, second property. Second property, I should have done the first, it's easier to say. So the first version of this is read-only, you can get it, and that's it. Second version, first name's read-only, you can change the second name when you want. Make sense? This one really makes sense? Cool. What if we want to add our own properties on top of it? Now, the personal ID fell down a bit for me here, because I couldn't think of a good example of where you do this in a person's name. So we're moving to rectangles now. Same sort of idea, we create a new rectangle width and a height, and we want to say, is this square? And we can make our own property, like this, and we have a get property, and if the height equals the width, it's a square. So that's the new properties. Make sense? But of course, we need a little bit, well, we don't need a little bit more than that, we often have a little bit more than that. So we might introduce a package which, in .NET land, think namespace, okay? We're going to import things so we can use them, so we've got a random object, I'll get that in a second. So that's a using statement, right? You'll notice here I'm importing Java util.random. I'm not using Java at this point, this is what I was talking about earlier, this is the JDK. It's just terrible with the names in my opinion. Right, so I'm not writing Java now, I'm just using something that Java has given us, the random object. Okay? And what we've got now is we've got our rectangle class, we've got our square property, and then we have some rectangle-based operation. I really couldn't think of a good thing that a rectangle would do here, so I print out rectangle things to the console. Okay? So we've got a function inside our class. We've also got a function that lives outside of our class. Now, this code, as is, if I put that into an editor, it would run, it would compile. Okay? But this method here, or this function here, just exists on its own. And that's called a top-level function. It doesn't exist in a class of any kind. Okay, so what you often see in C# is lots of static classes with lots of static methods in. In Kotlin, you don't really need that. You could have a package and have top-level functions in there and use it. You also notice that we new up our objects in this create random rectangle function, but there's no new keyword. You don't need it. So we new up a random object, which we import from the util package, and then we use it straight away, and we return a new rectangle without writing the keyword new. Okay, does that make sense for everybody following that? Cool, I think that's all we hear. There's nothing else on that. Cool. Let's talk about interfaces for a second as well. Interfaces are awesome. Can everybody read the code by the way at the back? Yeah, as I said, it's so this is an interface of dog. Notice I haven't put an I in front of it. That's because we don't read it in any language. But also it's more idiomatic not in the Java land. Yes, thank you. We also noticed that this interface actually has an implementation for the speak method, where the dog upon speak will say, woof. This is weird, right? I think C# 8 is talking about things like this, but it's not there yet. So default implementations of methods in interfaces is kind of confusing. You can't have access to members and fields and things like that in interfaces still, so you can work with what you've got. And if we were to use that interface, it looks very similar to C#. We have code on there, and we have the dog interface and my pet dog. And I'm going to override, again, it's just like C#, the chase tail method, and I'm going to print to the console, I'm going to run in a circle. Make sense? So we don't have to implement the speak method, because that's already on the interface. That's there for us. So when we new up a my pet dog class, we can call .speak, and it will print out as well. Right? There is a slight gotcha here. Can anybody spot what that might be? Okay. What if I do this? We've got two interfaces of cat and dog, and we've got a class that implements them both. It's my weird hybrid pet monster thing. They've both got a speak method with a default implementation. That's legal code. That'll work. So how do we implement that? And the simple answer is, you can't let the compiler decide for you. You have to explicitly say, this is the speak method I'm going to use. And do that a little bit like this. So I've got the despise you method from the cat, I've got the chase tail method from the dog, and then we've explicitly implemented the speak method to make issues. Okay. Which? I've got 3 microphones, excellent. Cool. Can you hear me? You better, I've got 3 microphones. So the speak method, we implement ourselves, and I've opted in this example to call the base implementation from the interface. So I'm calling the dog implementation first and the cat implementation second. You don't have to do that, you can write your own thing there if you want, so I'm overriding that function. Okay, so the super keyword, think base keyword in C#, right? It's basically the same thing. Ish. Make sense? Cool. Let's talk about data classes. Data classes are cool. So this is a data class. I've gone from an address, first line, second line, city, postcode, address. It's just like the other class definitions, except I've stuck the data keyword in front of it. And that does some really cool things. That implements the members for free for us. Okay, so if we were to create an instance there, we get the toString method implemented for free for us. So when we get the type output to the console, in this instance, we'll get a good variation of it. Okay, it does the hash code for us. So who here actually knows how to implement the get hash code method properly when doing equality? And who here relies on resharper to do it for you? Who here doesn't implement it at all? What are you doing? So it does the hash code method for us too. And then if we kind of output that to the console, you'll see here, this is with the toString version, and that's the hash code, which is a random thing. It does some other stuff too. This class is immutable, so it's get only, they're all vowels, right? So I can do equality checks quite easily. I can also do copying quite easily, because it's immutable, I want to be able to copy it, right? So the compiler will do that for me too. We can copy it here, and we can use like a named optional parameter, if you like, and saying, right, I'm going to change the city to Glasgow, and then we'll call the equals method, and the compiler has implemented all of that for me, and it just works. It's pretty cool, right? I think it is anyway. So, some further remarks on classes, okay? So, everything is final by default, and what that means is you can't inherit from it by default, okay? So think sealed in C#, where you put the sealed keyword on it, you can't inherit from that class. It's like that by default, and sealed has a slightly different meaning in Kotlin, which we'll get to in a little bit. If you want to make it so it's not final, you have to explicitly say it's open, so use the open keyword. And then, yeah. And then you already know what abstract means. It's the same sort of thing, right? It's just a class you can't do up explicitly, you have to inherit from it, right? Everybody with me still? Cool. In terms of access modifiers, there's public, private, internal, and protected. So public is the default, and they mean the same as they do in C#, so I'm not really going to go into them in a great level of detail. You know what they mean already. It's going to come natural to you. Okay, so beforehand when I said if you wanted to make this property a field in your class, just stick the private keyword in front of it, that becomes a field. So Java as a language isn't quite as good as Kotlin, which means the internal keyword will give you some surprises. And that's because the way it handles modules and packages and things like that. So if you want to use interop code, Kotlin does a lot of stuff for you to make it nice to use in Java, but it will throw some surprises with the internal keyword. I'm not a Java developer. If you are and want to use Kotlin, be aware of that and go look into it. Is that fair? Get out, yeah? And finally, nested classes are a thing, just like they are in C#, but they behave slightly differently in what they have access to and what they don't in terms of scope and things like that. I'm not going to go into that because I can't think of many times I've actually had a valid use for nested classes. But they are quite powerful in Kotlin, and I'd recommend that you go check them out and how they work too, because they are different to what you may know. Okay? Cool. This is a really, really cool feature, I think. Smart casting. It kind of blew my mind when I first came across it. And before I get into it, I've got to mention I've got Kotlin stickers. Come get some at the end. So smart casting, I'll move out of the way, is pretty cool. I'll give you guys a second to read the code so you can see what's going on. It's a really, really powerful feature, I think. So what we're doing is we have a marker interface in the form of shape, and then we have two classes that implement that interface, a square and a rectangle. And then in our function, we're saying if the shape is a square, print out to console, I'm a square, my length is shape.edge. If it's a rectangle, I print out to the console, I'm a rectangle, my longest side is whichever the longest side is. Can anybody see what's going on here? I'm able to use the edge property from square and the width and the height property from rectangle without changing that variable. I'm not casting that. I'm not casting shape, which is just the shape interface, to square or to rectangle before using that property. The compiler knows that in this block, it's 100% going to be a rectangle, so I'll let you use those properties as if it was a rectangle. So within this block, the compiler knows with 100% certainty that shape is a square, so I'll let you use the properties of a square. How cool is that? Yeah? But we can kind of make that code look a little bit nicer by using the when keyword, which is essentially pattern matching, I guess. And we can do something like this. So we have an interface. Again, this time we've got a circle class, because I wanted to show off that I knew how to work out the radius of a circle, or whatever it was, the area of a circle. So yeah, we've got a circle class. We've got a square class again. They're all exactly the same, and a radius with a circling. And we have a top-level function called getArea. Now, some of you might point out that you've probably put that getArea method on the interface. That ruins my demo, so I didn't do it. So what we're doing is we're doing the same thing again, essentially. We're saying, right, when the shape is a square, calculate the area this way. When the shape's a rectangle, calculate it this way. And when the shape's a circle, calculate it this way. Okay? And again, all of this code will compile as is. Right? There's no actual magic going on here. This is a screenshot taken outside of IntelliJ and pasted in. It just works. You'll also notice I've had to throw in an else, throw an exception, and there are only 3 shapes in the world. That's it, so we can't have any more. Got to throw an exception there. That's sort of annoying. Without that else, it's a compiler error because we're returning straight from this when block. So it has to match something, and if shape is anything else, it won't build. But we know that there are only 3 shapes. So really, we shouldn't need to do that else keyword. It should know that shape is only implemented in 3 places, and that's it, right? And we can do that by converting the shape interface into a sealed class. Okay, so there are some subtle differences here. We have to call the constructor on the shape now when we implement it. Okay, so because it's just a marker class, it's a blank constructor. But we have to call the constructor here, which is what these brackets are doing. Okay, and now when we get rid of that else statement, it will build. Because the compiler does some magic, and that's the best way I can describe it because I don't fully know what it does still. It does some magic and says, well, no, shape only has these implementations, that's it. If we were to add a triangle implementation, we get a compiler error. It's saying, well, you can't build this, there's a triangle, we don't know how to work out the area of a triangle. And I didn't know how to work out the area of a triangle, so I didn't implement it. So our code no longer builds because we've got a sealed class. So the compiler is helping us every step on the way to make sure we don't do stupid things, which in my case I really appreciate because I do stupid things all the time. There's something else I was supposed to say about this. Forgot. Extensions. So we all know extension methods in C#, right? Who doesn't know what an extension method is, out of curiosity? Okay, good. In Java, Java doesn't have extension methods. Idiots. They don't have properties either. We do. And we do in Kotlin too. So if we have, and I've started pulling things into packages now to prove a point. If we have our address class coming back as a data class, we might want to put extensions on top of that. So this comes in from an external library that we can control, right? In this example. We're going to want to add to that, add some functionality to that somehow. To do that, we can have extension functions, which is this thing here I'm in the way of. Now you'll notice some subtle differences to the way it works in C#. First off, there's no parameter magic in the function definition, right? There's an empty options there, right? There's no this and then the type of thing you're doing. That's because the type of extension we're making is here. So we've got the class here, address, dot, and then the extension function, right? So I'm importing from a different namespace, a different library potentially, and I'm adding functionality to the address. Now, that to me, join city and postcode, where we put city and postcode with a space apart, is really better off served as a property. So in Kotlin, you have extension properties, which don't exist in C#. Does anybody ever wish they did exist, or is it just me? Because it's really annoying. So to make that a property in Kotlin, it's the same thing. We should do address dot, and then it's an extension property all of a sudden. Okay? And I guess the reason this doesn't exist in C# is because the syntax of doing extension methods in C# requires parameters, whereas in Kotlin it does not. Because underneath, the getters and the setters of a property are methods, so I can't think of any reason why the CLI wouldn't support that. So Kotlin allows you to do that, and we can change our join city and postcode to city and postcode. To show what that looks like when using it, we'll import from our two different places, so we're importing our library and then our extensions. And we'll say, okay, here's my address, and then we're going to do my address.join city and postcode, print out, and that's going to print out city space postcode. Really simple stuff, right? And again, this will compile as is. If we want to use the property, we'll do the same thing. But you can get clashes quite easily, especially as libraries change over time. So when you import an extension function, you can actually rename it, okay, which is what I'm doing here. So I'm importing from jolib.addresses.join city and postcode, which is the function, and I'm saying rename that as city and postcode joiner. I'm sorry that wasn't very creative for these examples, by the way, and I couldn't think of a good name for it. But for some reason, we had a clash of that function because of other things going on in our massive code base that's been built upon for years and years and years. So we just rename it as we import it, and then we can start using it here. And underneath, the compiler will just swap it out and do exactly the same thing. Make sense? So sort of like using aliases in C#, but a little bit different at the same time. So you can do it on a function level, not a type level. Is everybody with me still? Cool, we're getting to the meaty bits soon. We're here. Lambdas. Lambdas are great. They have existed in C# since Link, which was C# 3. So 2007, 5, 7. You did talk on this. So lambdas have existed for a long time. They didn't exist in Java until quite recently. Java 8 finally added them, I believe. Again, I'm not a Java developer, so screw those guys. But Kotlin has them. And they kind of look how you'd expect them to look. So we're going to create a list of addresses, and we do that through a function. So this is quite cool as well. We've got a list of function that just exists in Kotlin land, and that will build up a list for us. So it'll be a generic list type that returns, okay? So instead of doing new list t, then list.add, we can just use the list of function that will do it all for us, okay? So I've got 3 addresses here. They're all fake ones, though to start with, I did put my real address in and opt against that because they were recording this, so, and I'm in Glasgow. So we've got 3 addresses that we're going to work with, and we're going to do some Lambda stuff with them. So the first thing we're going to do is, I'm going to move out of the way again. First thing we're going to do is get our addresses from a function. And again, we don't really need this function. It just made it easier to do the code samples, I'm not going to lie. We're going to get our addresses, and then we're going to find the one with the longest city address, which happens to be where John lives, in Ciderland. So the max by function, and we're then using these curly braces, right? And that's how we do our lambdas. So in C#, you kind of don't really need the curly braces. You can just throw in some weird syntax where you do the brackets and the equals, and it gets a little bit messy. Here, just use curly brackets, and that'll call the max by function with that lambda. So the longest city length in terms of characters wins the max by function. And if we want to do like link style things, Kotlin has some nice extensions on top of all of those collections for you to do it. So if we wanted to find the first address where the city is Glasgow, that's how we'd write it. And this may look a little bit more familiar to what you're used to in C# at this point. So we've got our lambda where we're going to have a, and then the type is address, and then we're going to have an arrow of some kind, and a city equals Glasgow, right? So there's a couple of differences between the first one and the second one. The first difference is we're not using the we're using it keyword on the first one. So quick show of hands, whenever you write some link or whatever in C#, who uses the variable x to declare whatever you're using? Right? Kotlin's like, yeah, you guys can give it terrible names. Just use the keyword it, because it is what you're doing, right? So it comes out of the box for free. You don't need to do all of this syntax. Just use it. If you want to give it a name, you can. But of course, Kotlin's good at inferring types, so we can get rid of the address bit and just do a arrow a.city equals Glasgow, right? So that is pretty much what you see in C#, but with slightly different curly bracket syntax, right? So you already know how to do most of this stuff already, and then we can print the current address out to the console. There's also the other type of lambda, which isn't link specific. It's what, did anybody go to Jonathan's talk earlier where he was talking about name delegates and functions and things like that? That's essentially what this is here, and that's some interesting looking syntax, but you do get used to it. So we take a function that takes in x and y of both int, and then we add them together, and then we can just call the sum lambda whenever we want, and yeah, it will work. So I thought I'd quickly mention something called as sequence as well. Okay, so this essentially makes this block here deferred execution, right? So event city lengths here isn't actually going to run until we iterate through it. Okay, so think, I can't even going to say this, think entity framework, where where you do your query or whatever, and it doesn't actually get materialized until you call toList or you iterate on it or you access some variables, right? Same sort of thing. By calling as sequence, none of this code gets executed until we iterate through it. Right, so if we've got something that we do quite a lot, but it's quite expensive to do right now, we want to do it later when there's more resources, or whatever, the as sequence thing will do that for us, and it makes it deferred execution, essentially. Magic. And then, yeah, you can loop over it like that. One thing I haven't mentioned with lambdas, which is a really, really cool feature, and it makes your code look super tidy and nice, are receiver lambdas and receiver functions. You can do that with the with and apply keywords. I haven't gone into that because the genuine reason is I couldn't find a good example to do it in front of you all. But they're really, really cool features, and I'd recommend go checking them out. They're called receiver functions or receiver lambdas. Really, really cool stuff, and it makes your code look super nice and super easy to read without assignments going on everywhere. Everybody still with me? Cool. So that's a super quick crash course on things I think are relevant in Kotlin. Now, there's so much I haven't gone into, simply because I've only got 10 minutes left anyway, and there's a whole other section we need to do. There's so much I haven't gone into. We'll go over some of that in a bit, I guess. But C# time, it's fighting time. How do they compare side by side? Now, I wanted to spend more time on this, but as I said at the start, introduce you to the JVM landscape, introduce you to a whole new language that you've never read before, and comparing it side by side was way too ambitious. So I've done a crash course through the first 2 bits, and now this bit hopefully will relate to you a little bit. So, a simple console application. Here's our C#. There's our Kotlin. But you'd probably write the Kotlin like that. And then somebody pointed out earlier that you can do the same with C# with expression bodied members, but that ruins my example, so shush. But yeah, so that's a simple concept application side by side. Again, these will both compile and run and build, and you can ship them, and you can put them in Docker and make your millions like that. You're welcome. Let's look at a real example, though. Let's look at a web application. And I wanted to look at a few more different types of web applications, but yeah, time is kind of not on my side here. So for C#, I decided to use the Botwin library framework. What are you calling it, John? One of those? Yeah, okay. And that sits on top of ASP.NET Core, and it gives us a nice way of doing routing. So here we're doing a listener, essentially, on anything that's slash. On the set, it's going to be 200. The content type is going to be text/HTML. I want to write to the body, my marketing app. Okay, I know that's pretty hard stuff, writing out to a body, but bear with me. If we were to do that in Kotlin, I'd have to move over to this side because there's quite a lot of code for this. We can use something called Ktor, which is a library. I think the JetBrains people wrote this as well, I'm not sure. And this here is an entire application with the Netty web server as well. So what I'm not showing you here is how to host it. What I'm showing you here is the entire setup of an entire application. This here will build and run. This here kind of won't, because you need extra bits. So essentially what we're doing is having an embedded server, taking in some arguments, doing some routing stuff. And the path helper things you see here, that's IntelliJ being helpful and saying, this is what this parameter is. And yeah, that's all there is to it. That is an entire application as a web server, and that will run and respond to requests. And I believe Netty, which is the server we're using here, is quicker at plain text requests than Kestrel is. Though that's a bold claim, and I don't know if that's true now that I've said it. It sounds like a lie, because Kestrel's really quick. But it's quick, okay? I'm sure I read that somewhere anyway. So that's our entire application there, and we can build that and run that, and it will go, okay? I'm not going to show you that running in IntelliJ, because it just writes out my marketing app to the browser, and there's no point. But as I said, there's more to the C# side that we're not seeing. We, of course, need our startup class to introduce our services and all the DI magic and the middleware to use. And we need our entry point in the program.cs as well to tell it to use the startup, to build it, and to run the web server. Okay? So I couldn't fit it all into one slide, but we've got one slide for Kotlin. So it's nice and terse, but still readable. So one issue I take with some functional languages is they're quite terse, but they become very difficult to read very quickly. Whereas Kotlin, I find, is very terse, and it maintains the readability. So that's something I really like. Yeah. Any questions on the web server bits, by the way? Cool, because I don't know much about them. Right, so things I haven't covered. I wanted to do more C# and Kotlin side-by-side examples, but time just was not my side for this, I'm sorry. So things I haven't covered in terms of Kotlin stuff, there's only one or two things that I've not mentioned. I can't remember how long this takes. It's quite a lot, though. Okay, there's more stuff still, but I ran out of space. So some of the interesting things, of course, local functions, they're quite cool. They're now in C# too, but they work a little bit differently. I've not shown you async with coroutines, because async, well, I'm not going to explain async to you in C#, a language I'm really familiar with, let alone a language I'm not familiar with. But it has async in there and coroutines, though I believe that is still marked as experimental. So be careful with that. But the example I showed you before with the Ktor stuff, that had a coroutine in it, async, you just didn't know it because I didn't point it out. Infix notations are a really cool way of doing it. So functions that take one parameter, you don't need to put brackets around, so it kind of reads like a nice DSL, which leads me on to DSLs. Not mentioned those either. The way it handles strings, really powerful. The type system itself is insanely powerful. Companion objects are great. Ranges, loops, I've not mentioned any of this stuff. There's so much to Kotlin, and it's really, really easy to pick up. So there's a couple of books I'd recommend. The one on the left here is a great book. The one on the right here is also a great book. They're both great books. God, I feel like I'm not going to say how I feel like right now. If you're interested, there was a link on the previous slide that I've just accidentally skipped. I'll go back. Stop playing the animation. There we go. If you're interested, there's a link there. I'd recommend everybody go to it and buy some of the books there. If you're interested in Android development as well, I believe Kotlin is now being considered like the de facto standard for Android development. Google are pushing it. JetBrains support it quite nicely with obviously IntelliJ and, of course, Android Studio. It's got support in Eclipse. Yeah, it's used everywhere. If you want to do Android development, check it out. I have no interest in that, so I can't tell you about it. But it's a really, really cool language with loads of cool features. And I've only touched on the surface as a quick crash course through it all. And the next slide is a spoiler to you all, I'm sorry. But that's me done, thank you. And we've got time for questions, if anybody's got some. Cool, thank you.